Good afternoon, everyone. Thank you so much for joining us. My name is Katie Rowley. I'm with the NOAA Central Library and will be your technical host today. A few logistics before we get started. As an attendee, you are muted, so no verbal questions will be allowed, but you can ask questions and there is a question panel for you to ask them through. We will be holding those questions until after the panel discussion, but please feel free to put those questions in throughout the panel discussion. Also, we are recording this session, so if you need to step away or if you would like to share this later with a colleague, the library will have this posted up on our YouTube channel. Since we are recording, anything that you do say in the question panel or in a chat conversation to us will be recorded and shared with the presenters after the fact, just so we cover all our questions and can follow up with you as needed. With that, I'm going to turn it over to Fiona Horsfall to introduce our Fireside chat today.
Good afternoon, everybody, and welcome to our 6th Fireside chat on transitions. As Katie mentioned, I'm Fiona Horsfall. I'm the Director of the Office of Research, Transition and Application, more commonly known as ORTA, in OAR. And one of our roles is to provide transition support with the objective of accelerating transitions across all NOAA and simplifying the transition process in general. Our goal of these Fireside chats on transitions is to provide participants with a broader understanding of research and development transition at NOAA. Before we go any further, I just want to thank my staff for putting this event together, Katie Geddes and Abby Arnold. And they've been working very closely with Andrea and her team to get this Fireside chat on track. In today's chat, we'll have a discussion on NOAA's testbeds and proving grounds and their role in transition. We will start with remarks from OAR's Deputy Assistant Administrator for Science, Gary Matlock, and follow with a conversation from our panelists for an in-depth look into how testbeds and proving grounds facilitate the research to operations pipeline and feedback to research. Our Andrea today will be Dr. Andrea Ray. Our moderator, I should say, will be Dr. Andrea Ray. Andrea is chair of the Testbed and Proving Ground Coordinating Committee and a scientist at NOAA's Research Physical Sciences Lab. She earned her AB in Geophysical Sciences from the University of Chicago, MS in Oceanography from the University of Delaware, and PhD in Environment and Society Geography from the University of Colorado. After years as a Canals Fellow at the Oceanographer of the Navy, she began her NOAA career in the NOAA Research Program Coordination and Development Office, later moving to Boulder to work on her dissertation on the uses of seasonal forecasting in water management as a project with the Physical Sciences Lab at Esrel. Her work since has focused on understanding use needs across timescales and transitioning research into applications and use in a variety of contexts. She became chair of the Testbeds and Proving Ground Coordinating Committee in October 2020. We encourage you to ask questions through the chat box. I think Katie outlined that for us. Questions will be sent to a moderator to ask. If there's not enough time to answer all the questions, questions will be answered directly via email after the session. As a note, on our website, we have a feedback form. We are collecting information on transition support, including a question on these Fireside chats to see how we can better serve our attendees. So please go ahead and look at the orta.research.noaa.gov website for that feedback form, and I appreciate you responding to that. Now it is my pleasure to welcome Dr. Gary Matlock with opening remarks.
Thanks, Fiona. Hopefully everybody can hear me. Great, super. As Fiona said, I'm the DAA for Science in OAR, but I've been involved in the topic of transition throughout my entire state and federal career, primarily in the fisheries world initially. And so getting science into the sphere supporting decision-making on aspects that affect society is something that is near and dear to my heart and fundamental to my entire science career, where I've applied it, provided the information to decision makers in order to affect society and make it better. So today I was asked to address the topic of test beds and the role that they play, test beds and proving grounds, and the role that they play in the notion of transitioning R&D into applications, the very broad arena, not limited to just operations in a 24/7 weather sense, but much, much more broadly than that. So I thought I would first refer back to the NOAA administrative order that defines a testbed as a working relationship for developmental testing in quasi-operational framework among researchers and operational scientists and experts. It is a place, can be physical, it can be virtual, can take on many different forms, but it is a place in which the results of R&D that are intended to be transitioned into an application are tested. They are examined to see whether or not in a quasi-operational setting, they actually can do, the R&D can actually do what it is intended to do. As a result of that, the RL at which test beds operate is typically RL 7 or 8, because there is testing going on of a product of R&D for the potential of being applied, again, to make society better, hopefully. As a result of that definition, the notion that a test bed is a research arena, it's where R&D gets done, is essentially sort of antithetical to the idea of how we go about getting our R&D into an application. Now, there is R&D that goes on in that arena, because if a particular product does not succeed in meeting whatever requirements or criteria that have been established in a quasi-operational environment, then there has to be some examination if folks think that the particular product might still be useful, even though it may have failed some of those criteria. So there has to be R&D that goes on in order to address what's learned in a test bed. But the test bed is not fundamentally the place where the R&D occurs. It is the place in which the testing of that R&D occurs in order to determine whether or not it can be converted into an application. I'm very fond of using the analogy of United Laboratories, where if you look at the wall sockets or the electrical sockets on a wall, you'll find that there is a UL certification on those particular outlets that indicates that before they got to me in my house, they have been examined to see whether or not they satisfy the criteria of those plugs doing what they're supposed to do, which is transmitting electricity out of my wall into a particular appliance. If that testing had not occurred by United Laboratories, then I might go buy something and have no idea whether or not it might or might not work. That whole notion of then using United Laboratories as the place where there can be a determination made that an RL8 product can go into RL9 application has a very, very focused purpose for test beds and proving grounds, or for United Laboratories. So it's an effort to try to accomplish the notion of getting our R&D converted into applications. Test beds, therefore, serve a very, very significant role, a very significant purpose, and I would hope that in the future, as they are used more and more in NOAA, that we find them very prominent in transition plans, where the R&D individuals and the individuals that might apply the R&D are involved in a test environment, test bed or proving ground, articulated in a transition plan, so that we have a better notion of what will occur to go from R&D into applications. At the moment, test beds and proving grounds are not very prominently identified in transition plans, but the future, I hope, has a different representation of their significance in the entire process. So with that, I'll end my comments by thanking both Fiona Andrea, the Central Library, and all of you participating in the Fireside chat today for giving me the opportunity to offer a few opening comments. Thank you all. And over to you, Andrea.
Thanks, Gary. Yeah, thank you, Fiona, for that introduction. There's 12 test beds and proving grounds across NOAA, and we're gonna hear from 4 of them today. And they'll all talk about collaborations they have. So I kind of suspect that we're gonna hear most or all of them mentioned in the course of the next hour. And I want to start by elaborating a little bit on the definition that Dr. Matlock gave. The terms test beds and proving grounds are used, or TBPGs for short, are used in a lot of other contexts. So what we mean here is multi-project ongoing efforts that are really partnerships between research and operations. The testbed and proving grounds facilitate, as Gary says, the orderly transition of research capabilities to operational implementation or to other applications, although for the most part today we're going to be talking about operations. And this happens through the development and pre-deployment testing of research for operations, as well as the evaluation of the suitability for operations and operational readiness. And what I mean by suitability is if you've got a forecast that goes out every 6 hours, and whatever new thing is that's fabulous and does something great to make that forecast better, but it takes 12 hours to run, it's not suitable yet for operations, and it's not operationally readiness. And Joshua Scheck from the Aviation Weather Testbed is going to tell you they worry about things on the minute scale. So do some other parts of the Weather Service. And if you're sitting with your tush on the plane seat and you're wondering when the fog is going to clear in Seattle, as I was a few days ago, it's minutes, but you get the point. So you can have something that's great, but is not quite yet suitable for operations. So I want to emphasize there also that these are really a back and forth between research and operations, because if you've got something great like that, you want to talk to the research people about, you want to iterate and find out how can you make that work, because they want to use that better forecast. So these really are partnership. They're not a linear handoff between research to operations, or what we might call R2O. The test beds work really closely with R&D, those PIs, and as I said, any innovation is often iterated before moving to the next step. And they also feed back their interest to research, what we might call O to R, or operations to research, where research is informed by having this interaction. I also want to emphasize the diversity among the test beds and proving grounds. And you'll see from these four examples, how they function, who they collaborate with, how their work is funded, and what NOAA line offices and other agencies they serve. And so they're really crucial for the uptake of research into operations at NOAA and other partners, and ultimately for the realization of societal benefits, as Gary discussed. So this fireside chat is gonna provide an in-depth look into this as best as we can in an hour. And with that, I'm going to briefly introduce the panelists. I'm going to defer you to the webpage for the longer introductions. I'm just going to do a brief introduction in the interest of time. And then I'm going to let them introduce themselves a little bit further and their testbed approving ground through the first question. So and just to let you guys know, for the first 2 questions, I'll call on you in the same order that I use right now. Alan Gerard of the Hazardous Weather Testbed is also chief of NOAA's Severe Storms Lab Warning and Research and Development Division. Louisa Nance, who's the director of the Developmental Testbed Center, which is a joint effort between NOAA and NCAR and some other agencies. She's at NCAR. And Joshua Scheck is the Aviation Weather Testbed, and he's the chief of the Aviation Support Branch of the Aviation Weather Center of the National Weather Service. And Dan Lindsay from the Satellite Proving Ground is also the NESDIS GOES-R satellite program scientist. So let's start with the first question. And I'll start with Alan. Could you each, I'm not going to repeat this each time, but give a brief overview of your testbed or proving ground and tell us a little bit about where your work is typically transitioned. Alan.
Sure. Thanks, Andrea. So the hazardous weather testbed is a physical space that is co-located between NOAA Storm Prediction Center, the National Weather Service Weather Forecast Office for Central Oklahoma, the Norman, Oklahoma City office, and the National Severe Storms Laboratory. So we like to say it's both a physical space, but it's also a concept. It's basically a framework by which those three entities work together to test and develop new products, tools, primarily focused on convective forecasts and warnings. But you know, basically, I mean, we've tested things that vary from flash flood forecasting tools to severe weather, to tornadoes, to early on aviation. Some of the ways in which some of the other test beds, like the hydrometeorological test bed and the aviation weather test bed, got going was out of work that was originally done in the hazardous weather test bed. So even though we're physically, you know, this one structure, in some ways we're almost like three individual test beds. We have an experimental warning program, which is primarily focused on like the 0 to 3 hour time frame, where we test and evaluate new tools for convective warnings. And the products that are tested in that program tend to be transitioned into National Weather Service warning forecast operations. So either into the actual WFO environment itself or into some sort of a weather service operational environment that produces products for the WFOs. Then we have the experimental forecast program, which is primarily operated by the Storm Prediction Center and NSSL's forecast division, which looks primarily at modeling, at convective allowing models, and how output from those models can be utilized in Storm Prediction Center time frame of operations, anywhere from mesoscale discussions out to their convective outlooks that go out to several days. And most of the products and techniques that are tested in the EFP go into Storm Prediction Center operations. And then lastly, we work with Dan and the folks at Hazardous in having a satellite proving ground kind of outpost here at the HWT, where we focus on the application of satellite, new satellite products and techniques in convective forecasting. And so I think that answers everything.
Yeah, thanks, Alan. We'll move on to Louisa and Developmental Testbed Center.
Hi, everybody. So the Developmental Testbed Center is actually a partnership between NOAA and the U.S. Air Force and the National Center for Atmospheric Research, or NCAR. And we have staff who are affiliated with NCAR, and then staff who are also affiliated with NOAA's Global Systems Laboratory. So we're a distributed facility in that respect. So our focus for our testbed is looking at evaluating model innovations. So developing new physics parameterizations, data impact studies for data assimilation, the full gamut of that. So it's very focused on improving the skill of the numerical weather prediction models run by NSEP. We're not focused on any particular type of weather phenomenon. So we work on, can range from short range weather forecasts, longer range weather forecasts, winter weather, summer weather, tropical cyclones. We even do testing for innovations directed at improving those models. So it's a pretty broad range from that standpoint. And we do have interacted over the years with the Hazardous weather testbed, Hydrometeorological weather testbed. Oftentimes from the standpoint that central to what we do, we're developing advanced verification or evaluation toolkits. And so working with those different test beds on applying those tools and trying to provide sort of more in-depth information, and also working with the data sets that are available through those test beds to do some more diagnostic dig in, better understand where the models are going wrong, where they're doing things right. And so because we're so focused on the models that are behind the scenes, you know, our testing, actually, I would say our work can span more from these readiness levels up that are less mature, so more in the maybe RL3 or 4, all the way down to like RL8. And basically where our testing lands is is with the Environmental Modeling Center. So we're basically doing testing within a modeling framework. So getting those innovations into the codes that actually have the operational configurations in them, doing those side-by-side tests, and then basically handing that off to NCEP's Environmental Modeling Center, where they take it that last mile towards you know, wrapping up multiple innovations and testing them together, and then handing those off to the NCEP central operations. So that's where the little niche, or maybe I should say large niche, that our group contributes to a broad range of looking at model innovations. So I think that covered everything.
Thanks, Louisa. We'll move on to Joshua Sheck and Aviation Weather Testbed.
Hi, thank you, Andrea. Thank you, everyone. The Aviation Weather Testbed is unique compared to the descriptions that you've heard, in that it's co-located with only one operational entity, and that's the Aviation Weather Center. Here at the Aviation Weather Center, we receive requirements or strong requests from the FAA to provide very distinct services to really safeguard the efficiency and safety of the national airspace system. And that even gets expanded into a global scope, as the International Civil Aviation Organization, ICAO, works under the UN as a group that defines world area weather for aviation purposes requirements and products. They are the ones who set those standards, and then those fall into the National Weather Service as service requirements to deliver. So what we do in the Aviation Weather Testbed varies from a smaller scale. How can we better close the gap in consistency between forecasts at a TAF level, between these clouded or these gridded clouds that we're providing you as a forecast, for instance, and the actual ceiling heights and cloud heights that you're being shown in a TAF? How can we close the gap when those two numbers are different? All the way out to how can we provide you cost saving and safety based forecasts when you're flying from Singapore to LA, or from New York to Brussels. So it can be, our partners vary from FAA and the the national aviation weather enterprise partners like IBM, who provides information and forecasts, the airline operators, oh, of course, I forgot an acronym. The AOPA group, basically pilot groups that interface with the Aviation Weather Center and the Aviation Weather Testbed, both in a virtual sense and as a physical space for experiments. So with all that said, our primary focus often takes one of two paths. We work very closely with the FFRDCs, the federally funded research and development centers, as they are oftentimes funded by groups like the FAA or the Department of Defense to create algorithms that are very aviation focused, with the intent that it helps the National Weather Service meet our service needs. So, we may usher in through the readiness levels a new technology that's science-based through the test bed to validate that users can understand it, that forecasters can build it into their workflow, that the technology is reliable and the latency isn't too great, like Andrea referred to. We care in many cases about minutes. And then we are the facilitators of getting that transition to an operational status. Similarly, while we're not hardcore research developers, we also do have to develop things in order to meet requirements when they're strategically beneficial to both parties, the FAA and the Weather Service, or another partner in the Weather Service. So there is some development and there's rigorous testing with partners. So I look at the Aviation Weather Testbed, to sum it up, it is the focal point of research to operations in the form of risk reduction that is based on partnerships, because that's really where everything comes together, and it's so difficult to measure or describe until you're part of it. So thank you, Andrea.
Yeah, thanks, Joshua. We'll move on to Dan Lindsay, and he's with the NESDIS Satellite Proving Ground. Dan?
Great, thank you. Can someone verify you can hear me? Okay, perfect. So good afternoon, everybody. Yeah, so as Andrea said, I'm representing the Satellite Proving Ground today. This is a group effort, really. Mitch Goldberg is really the head of the group. He wasn't able to join us today. So the Satellite Proving Ground began around 2010 or so, and the original intent was the preparation for the launch of the new geostationary satellite series called GOES-R. It was planned for launch in 2016, and so the idea here was to test new products and new satellite products and operations, and to get forecasters used to those products before launch, so that once we turn the key and we put the satellite into orbit, then immediately the products begin to flow, the users know how to use them, and they're ready for it. It was really successful. In some cases, the way this works is we were able to send proxy satellite products before the satellite launched via, say, model output, or maybe some other satellite data, for example, from other parts of the world, such as over Japan. Send those to Weather Service and to users, let them take a look at them, and then give feedback and say, well, this product really could use an improvement. It would work a lot better if you would make this change. And that's a good example of how the feedback not only goes from a research to operations, but we actually get operational feedback back to the researchers themselves, who can then tweak the product and make it better. So that was a successful effort. We expanded it to include the JPSS series in the I guess around 2015 or so. And so now it's really a group effort with all of NESDIS and all of the operational NOAA satellites. Now, after we did launch GOES-R in 2016, we realized that this was still a very useful program to have, because we still are producing new products. There's things that are being learned every day with the new satellite data that's coming in. New products are being developed. Machine learning, for example, is being used a lot to come up with new products. And so we still do have a means to go out to the Weather Service and to other users and demonstrate these experimental products, get feedback, and then put them into operations. And then to answer Andrea's second part of the question is, where do the products go to operations? It's primarily one of two places. One is NESDIS themselves. They do have an operational arm, which is known as OSPO, yet another acronym. And so some of the products do become operational within NESDIS OSPO, which are then distributed out to users. The second way is through Weather Service. One example of that is a product known as the ProbSevere product. This provides, it's really more than just satellite. It uses satellite and radar near storm environment information in order to say the probability that a given storm will become severe. And that product ultimately was implemented and became operational within MRMS within Weather Service. So again, there's a multiple different ways for these satellite products to make their way into operations.
Thanks, Dan. And thanks all of you. And we're going to go around to a next round, starting with Alan. I would like you to talk a little bit about what you see as the role of your test bed in research to operations in particular, and you can talk a little bit about going and the feedback to research. And could you give a specific example?
Well, I would say that the primary way in which we participate in the R2O process is through facilitating co-development of new products and forecast techniques. So, I mean, what we really try to do is foster an environment where we bring together the researchers, the practitioners, whether that be weather service forecasters, emergency managers, broadcast meteorologists, and academic partners, bring them all together into the same environment where they can essentially look at whether it's a displaced real-time weather event or an actual live ongoing weather event, to look at the various products and techniques that are being evaluated and work together to see how the practitioner might use them in their day-to-day job, whether it's a forecaster issuing a warning or an emergency manager making some sort of a decision about, so needing to take protective action for some particular group. We have this environment where that co-development can occur. And I mean, there's a lot of different examples I could go into, given our the various efforts we've had across the warning and forecast programs and the satellite proving ground. But just to pick one, that I think people will probably have a lot of familiarity with is the development of the convective allowing modeling system, the HREF, the high resolution ensemble forecast system, which has been operational now for several years in the Weather Service as a primary ensemble convective allowing model system, and that became operational out of that co-development that occurred within the hazardous weather test bed, where you had SPC and WFO forecasters working side by side with researchers and academic partners and working together to see how those models could be applied to operations, and seeing what the best, and working with like DTC. DTC was an important partner in the other labs to see which models verified best, which model should be part of the new ensembling forecasting system. And through an iterative process of several years of co-development, we ended up with this operational modeling system, which plays an important role in day-to-day operations of the Weather Service in a number of operational areas.
Great, thanks. Nice. Louisa, I'm going to move on to you. And I neglected to say, for this question, let's try to keep answers to about 2 minutes.
Okay. I'll try.
Yeah, good luck.
Yeah. So for the DTC, I would say our role in the supporting R to O to O to R, whatever, is it's sort of twofold. One is enabling, whether it's internally or supporting the community, to conduct really robust testing evaluation of innovations within the modeling framework. And when I say robust, so challenging that innovation to a variety of weather circumstances. So making sure that while it was developed to address one problem, that it hasn't adversely affected the forecast in other situations. So making sure that it's going to improve the skill of the models overall. And that generally includes needing to look at a large sample of forecasts and look at a large range of metrics, evaluation metrics, statistics, that kind of stuff. So that's sort of one aspect, supporting the R to O process. And then supporting the O to R process is taking and using some more advanced verification diagnostic tools to dig into, provide some information to the model developers about why the forecast seems to be going astray, not doing well in certain circumstances. And so providing that feedback to the model development process. And that feedback goes to a wide range of model developers that we engage with. So those model developers might be associated with one of the NOAA research laboratories, or they might be from the private sector, or they might be from academia, or from an FFRDC. So it's trying to have that broad reach to the variety of research folks. And I would say, so one example, really quickly, we've done some work supporting the hurricane, the development of the hurricane model, which is currently HWRF. And we engaged with a variety of physics developers who had some innovations that looked promising, helped them set up, and we conducted some of the testing, they conducted some of the testing. But it ended up being a very iterative process, because some innovations right out of the starting block didn't do so well, provided some feedback to them about why it didn't seem to be doing so well. And then, they went back to the drawing board a little bit, and tweaked things and looked at how to improve, and actually ended up, in one example, it being a combination of development or advancements of physics schemes, because there's complex interactions between them. And so, you fix this, but you got to fix this in this other scheme. So it was like the clouds and the radiation and bringing all of that together, and then ending up being able to transition those into operations. So hopefully that was close enough.
Really, yeah, really useful example for me. Joshua, I'm going to let you have a stab at that question.
Andrea, to keep it short, I'll focus on an easy one. We partnered with the Meteorological Development Laboratory, who had a focus on gridded lamp data, and they were providing the ceiling and visibility information on a fine scale grid that really was doing as well as, and also higher resolution as the previous operational National Convective Analysis product. So we partnered with the FAA's Aviation Weather Demonstration and Evaluation social scientists, who conducted focus groups with users. We did a formal evaluation, and we facilitated with parts of OAR that I believe provided some verification, validation information, as well as understanding how users were interpreting that data, and we focused on display. So we took all of that information together. The experiment actually involved some pilots flying in. We had one from North Dakota and one from Colorado, who flew all the way here just to meet in person for focus groups. And then that information was translated into requirements when we went through the FAA's safety risk management process, which you have to do for any big change in a service. They actually removed some of the fine print liability because they determined that we had reduced risk beyond where it had previously been, and they passed it through with no amendments. So a good example of how the test bed was the focus of all of that activity. And by leveraging partnerships, we improved service, got a better product out there, and we did it while managing risk.
Great example. Thanks. Dan?
Thanks. Yeah, to be quick, I'll just go to a quick example. Some number of years ago, I don't know, 5-6 years ago, we were at a meeting with Weather Service, a proving ground meeting, and they expressed the need to improve the forecast of smoke from wildfires. You know, of course, this is a big problem, especially out west, getting worse with time. And so we collaborated with OAR, the lab down in Boulder, to combine information from satellite, from VIIRS to get fire hotspots or fire radiative power to use as sort of an initialization point of the HERS smoke model, which was the OAR side. And that model then tells you where the smoke is going to go. This was evaluated as part of the proving ground and has now become operational and is used pretty regularly now. You regularly see these smoke forecasts from the HERS smoke model. So I thought that was a pretty neat example.
That's great. So, Katie, do you want to do a time check? I see we're at about 12 minutes after the hour. I can move on with, I don't see any questions from the audience. I can move on with a couple of more questions and I will now ask the audience. Oh, yeah, thanks, Ryan. I'm going to ask a question from the audience. Thanks, Ryan Solomon. If you had to name your testbed's single biggest challenge, what would it be? And I'm going to let one of you raise your hand if you want to start with this. All right, Dan.
So the biggest challenge we found is sort of the final mile of operational transition. It's sort of getting the product actually operational in the 24/7 operational system and everything that goes along with it. There's a lot of work that goes into the steps prior to that, you know, testing, evaluating, tweaking, etc. But for whatever reason, it does seem like there's often a bottleneck when it comes to the actual transition itself. And I don't know if that's consistent with other groups besides NESDIS, but at least from our standpoint, that seems to be the case.
Would any of the rest of you like to elaborate on that? Yeah, Joshua.
Yeah, Dan, it seems like there's such an influx and interest in leveraging all of the great science that does exist, all of the great R&D. That we have cooperative institutes. We work with Colorado State University. Several of you are associated with universities, the test beds. We do all that, and there is a lot of focus on moving science and technology forward, but the operational infrastructure and that last mile that we've been hearing about for well over a decade, that is really the challenge. We can bring people together, we can solve any problem, but we can't reallocate where funds go to make sure that there is a system that's ready and supported at the end.
Louisa.
I'll say for our group, probably the biggest challenge is keeping up with the various development efforts that are going on and being able to connect the community with like the right version of the code and how you get your innovation in there, and keeping up with the whole fast pace behind the scenes. While implementations only happen so often, the development is a continuous cycle. And so you've got somebody, we're trying to enable people from outside of that core development group to be able to bring innovations in, but being able to connect them with that process is a really big challenge, so that when you do a test, it's relevant to the current version that's being developed of the code.
Okay, I'm going to look at another question from the audience. Are there any published guidelines or documented best practice for the nitty-gritty details of establishing an R2O pipeline? And I'm gonna, one of the questions we had in our back pocket was talk about what kinds of metrics you use to decide if a project is ready to move to a higher readiness level or a next stage in transition. Who'd like to answer those? All right, Joshua.
I can only partially answer that because it won't be satisfying. In our test bed, it's not that we don't have metrics. At times we're testing latency, we're doing verification. But really a lot of the work is more of an identification of problems and then a creative solution to those problems. And we have, I was perusing the attendees, and we have a team here of highly successful developers that think creatively and they solve problems. The matrix that I think partially answers your question is the readiness levels that have been talked about are fairly well defined in a repeatable process within the aviation weather test bed. So we do have criteria that describes expectations, it describes level of supportability of a given capability. It describes the level of IT security scrutiny and number of hours per day that something gets supported, so that it's not all loosey-goosey creative think tank, but yet it's a little bit more intuitive in our case, where we're not necessarily tracking every number on a system.
Anyone else? Otherwise, I'll move on to the next question from the audience. Ken Vieira asks, what readiness levels do people usually enter using the test beds? Is it like RL7 or higher or lower? And I'm just going to say, yeah, it's about RL7, but then it sometimes is subject to the vagaries of how a PI assigns the readiness level, but it's generally in that order. Alan.
I'll just real quick say that in the case of the HWT, I think that some of our evaluations occur at a little bit of an earlier readiness level because we're really trying to co-create R&D pathways. We have partnerships, interdisciplinary work between social science, physical science, end users, and because of that, we're trying to make sure that we don't get too far down a particular path and find out, that it's a dead end. So we're trying to kind of work things a little earlier than that. I would say maybe more like in the 6-7 range, and then eventually, especially for stuff that goes into warning operations, goes into WFO operations, we would theoretically at least hand it off to the operations proving ground to take it to that last 8 to 9 transition process.
I think it's also a tough question to ask because different aspects of a project may be at different levels. It's and then I see you guys nodding, so I'm going to ask you to jump in. Lots of times there are different aspects. There's the numerical guidance. There's the is it ready for the WFOs to use? There's the what have the social scientists thought about how people cognitively process this? And at any of those different things could be at a lower level, or just to emphasize this iteration. Sometimes you answer one of those questions and you realize you need to jump back and do some other development. I don't think there are any other questions. I'll keep an eye on that. how do you set priorities? Just a minute or two on that. Joshua.
That's a great question. The priority setting really comes down to what are the strategic goals of the organization? What are the requests from your partners? And what's possible? And then I think you need to manage expectations. We have problems we can't solve yet, but they'll get solved, right? So how fast that moves and how many of your resources solving that problem takes has to be balanced with what is possible and which things move you closer to that strategic goal and that improvement in service.
Great. Anyone else have a thought on that? Louisa.
So not to delve too deep into, but our priority setting is maybe a little more complicated because we are a partnership where we have multiple sponsors. Because we have funding from NOAA, we have funding from the Air Force, and we have funding from NCAR. So we have an external management structure. So we have a science advisory board, we have a management board, and we have an executive committee. And our science advisory board is supposed to be providing us with strategic guidance about what's on the horizon further out with respect to development and areas that we should be on the outlook for. So that board has membership from academia, private sector, the NOAA research laboratories, and other agencies also. And then we have a management board, which has representatives from each of our partners. And so they play a big role in defining the priorities with some guidance of input from the Science Advisory Board. But each entity, governs its own funding. So we get together and we discuss, what's on the outlook, and then each partner determines what the priority is for their funding. And then our executive committee ultimately approves our plans. So it's got multiple stages, and that's how it ends up playing out. What available funding there is and what the priorities are for the respective agencies.
Okay, that's a great place to jump off into another question from the audience about where does funding or other resources come for these activities? And I'd also like to see if we've got just a minute at the end to say if a PI wants to get involved with your testbed or proving ground, how would they go about doing that? So let's start with funding. Anyone want to jump in? Dan.
Yeah, so from the satellite perspective, the way that NESDIS does it is the satellite programs themselves, whether it be the GOZAR program, the JPSS program, et cetera, they set aside a pot of funds for this very purpose, for product development as well as product, checking it out in the proving ground. And so that generally is where our funding comes from. Occasionally we will partner with other groups, with other parts of NOAA who may have their own funding lines, but for the most part, it is something that's planned ahead of time from with the satellite programs themselves.
How about for some of the others? Alan.
Yeah, a large part of our funding comes from the various programs that the Weather Program Office manages, the USWRP and JTTI programs. They have competitions which fund specific projects which end up in being evaluated in the test bed. And then we also get infrastructure support from those programs to help fund equipment, personnel, the sort of things that you need to be able to operate a test bed. And the HWT has become almost a 12-month operation at this point. We're having experiments all throughout the year, and then the individual agencies contribute as well. NSSL, the Storm Prediction Center, the Weather Service, STI, all of those groups also provide both funding through funding staff and specific financial funding. So it's definitely for something as large as the HWT. It's definitely a joint effort.
Great. Louisa.
So I'll just plug on the part where the question about PIs getting involved. So while the DTC right now isn't getting funding through the NOFOs, the Notice of Opportunity funding opportunities, whatever that acronym stands for. We do have an avenue for researchers to get engaged with us through our visitor program. So basically, folks can apply to come work with us. They need to have a project that they propose, which goes through a review process. And there's limited support we can provide for that, but that is one way that we can reach out to the community and facilitate some engagement on that front.
Great. So I see we've got about 3 or 4 minutes left. Katie, do you want to jump in now, or shall I get a couple more responses to this?
I think you can get 1 or 2 more responses in there.
Yeah. Josh, how about you? How would somebody get involved? You mentioned the federally funded R&D offices.
Yeah. So we do have a history of working with the Weather Program Office projects with universities and FFRDCs. It's a little more complicated with us because FAA also funds some of the testbed activities as well as STI. So if you're a PI and you want to get involved, to me, the first step is reach out. Let's build a relationship. We're pretty big at the Aviation Weather Testbed. We go to AMS, we go to their presentations. This really all starts with a relationship. I know science is the wonderful focus of what we do, but the art of what Alan's talking about with getting the decision maker, the user, the forecaster, the developer, all in a conversation, that's where the magic happens. So that conversation needs to start if you're a PI, so that we can put you in touch with the right things, the right entities.
Yeah, that's great. And I'll just jump off and say that, yes, most of the test beds and proving grounds are going to have 1 or more activities at the American Meteorological Society meeting. Come to the NOAA booth. I'm going to be giving a talk on the Test Bed and Proving Ground Coordinating Committee, and there may be some other test bed talks at the NOAA booth. Stop by the NOAA booth. I don't know where it's going to be, but you'll find it if you're at AMS, and ask about that, and just search on test beds on the AMS program. That's the word I'm looking for.
And
so
I'll just quickly say,
Dan, go ahead.
Really quick, I'm sorry, Andrea, I didn't mean to interrupt, and
Please.
mention the AGU meeting as well. If anybody happens to be at AGU in Chicago, which is about, I don't know, 3 weeks from now, be sure to stop by the NOAA booth there and say hello.
Yeah, I'll be there as well. And we'll also have a talk on the test beds and proving grounds at the NOAA booth there. That one's going to be 3:45 on Wednesday. So I think you can bring your beverage of choice. You know what kinds of beverages they have in the afternoon at AMS, at AGU. So, Katie, would you like to wrap things up?
Yes, I would. Thank you so much, panelists. I will just remind everyone that we did record this. So if you would like to go back and listen to something more closely that you might have missed last time, it'll be up on the library's YouTube channel. I'm going to turn it over very briefly to Fiona Horsfall to talk about the next Fireside Chat.
Yeah, I just wanted to make an announcement that our next Fireside Chat, we're aiming for February, and that is going to be talking about what does it mean to be operational, what is an RL8 versus an RL9. And I think that that'll be a super interesting topic, and I'm sure we'll have a lively discussion. So look out for information on that. And thank you to all our speakers and to Andrea for this super interesting discussion we've had here, and I'm hoping that our audience has learned a lot from it. Thank you.
I learned a few things. So yeah, thanks everybody. Thanks to all the panelists for your great engagement on this.
Thank you all. Take care, be safe, and the U.S. won our World Cup match, just for everyone in the audience who didn't get to pay attention. 1-0. So take care, all. Thank you.